Okay, so these are notes for volume day 3 of our unit 5. We are looking at how do I find the volume of cylinders, prisms, cones, pyramids, and spheres. So the first thing we want to know is that volume is the space of is the measure of how much space something takes up. So how much could I fill something up inside? So for example, if I have this is a triangular or a square pyramid. So how much space is inside of it? If I was to pour something into it, how much space would it fill up? Well, here I have this is a triangular prism. How much cardboard did it take to build this triangular prism? So how much space does something take up? One thing to know is that our units are always cubic for volume, so feet cubed, inches cubed, miles cubed. You could also pronounce this cubic kilometers, cubic centimeters, cubic meters. So over here, we're going to start with our basic volume formula. So what we're going to do here, and it doesn't matter what we are finding the volume of. So here I have a triangular prism. Doesn't matter if it's on its side, turn left, turn right. But what I'm going to do is I'm going to find the volume of this. So what I'm going to do is I'm going to start by focusing on one of the bases on this pyramid, or on this prism, and I'm going to find the volume of this, and then I will figure out how deep it goes and multiply it by its depth. So my basic volume formula, volume equals capital B times H, and this capital B represents the area of the base. So when I look at this shape, this triangular prism, the base is a triangle. So step 2, what I'm going to do is I'm going to substitute in the base formula. So the base is a triangle, and my formula for that is base times height divided by 2. And I'm going to use that to find my volume. So I have this triangular prism. What I'm doing here is I'm using this formula to find the area of this base, base times height divided by 2. And then this height is going to represent how tall the entire prism is from base to base. How tall is it? Or how deep, one of you might say, to go from the front to the back. So this base and height comes from just my base right here and right here. It's important to know that base and height always meets at a 90-degree angle. So these are going to be the two numbers that I plug in. I'm going to use the 5 as the height, and I'm going to use my base as 24. And then the height of the overall prism is right here, 13.5. This slant height and this slant height I do not care about. So when I'm calculating this, I do not care about here or here or here. I just want to know these two at a 90-degree angle. So now this is something I can plug into my calculator. 24 times 5, and I'm going to divide that by 2. 24 times 5, and then divide that by 2. So this is 60 times 13.5. And so that times 13.5, my volume is 810, dealing with cubic feet. So this is my final answer for how much space is inside my triangular prism. On the next one it says a circular swimming pool can hold 7,850 cubic feet of water. The diameter of the pool is 50 feet. Find the height of the swimming pool, and we're going to use pi, 3.14 for pi. So it's got a circle on top and a circle on bottom, so this is going to be for a cylinder right here. So I'm going to start out with my basic volume formula. Volume equals capital base times height. And the base of this shape is a circle, so I am going to plug in the circle formula for this right here. Circle formula is pi r squared. Okay, next I'm going to look at what is pi r squared. We know pi is going to be 3.14. And it says the diameter of the pool. So if here's my swimming pool, the diameter all the way across is 50. And we need the radius. The radius is right here. That's going to be 25 feet. So times 25 squared. And then I can multiply that by the height of the pool. Now, if we reread the question, find the height. So I don't know what this is. And the only other number I know is right here, 7,850 cubic feet. That is a hint. It says can hold that much water. That is my volume, 7,850 feet. So we need to do this, not to find the volume, I know that, but to find my height. So I'm going to go ahead and simplify this stuff on the right. I'm going to simplify this right here. I'm going to go ahead and type that into my calculator. 3.14 times 25 squared. So I get 1,962.5. That is still being multiplied times h to get the 7,850. Now, just like we would work any inverse operation problem, I want to get rid of this by doing division. So 7,850 divided by the 1,962.5, and I get 4. So h equals 4. So we know the height of the pool is 4 feet. So the height of the pool is 4 feet. Okay, so in class we did a little investigation on how a cone and how a cylinder relate to each other. These two cones have the same exact height, they're the same height, and their base is the same size. These are exactly the same size. And what we talked about in class was how 3 of these fit into one of these. So if I filled this up with water, it would pour 1, 2, 3, and this would be full. Or another way to think about it is this, a third of this equals one of these cones. So when I want you on these problems, anything that goes to a point, when we do our basic volume formula, it is 1/3 base times height. Anything that goes to a point. So what I mean by that is I mean my cones and my pyramids, anything that goes to a point, that will have a 1/3 in it. Same thing holds true right here. I have a pyramid and a cube, a square prism. They have the same exact height, and their base is both a square that is the same exact size. If I take this and divide it by 3 and take this and take a third of it, it will fill up this exactly. So 3 of these equal 1 of these, and this times by a third gives me 1 of these. So I'm starting with this formula because it goes to a point. Now I'm going to substitute in my base formula. My base on this is a circle, so that is pi r squared. And so we've got volume equals 1/3 pi r squared times height. My diameter is 24, so that means that my radius is going to be 12. So I'm going to plug in a 12 right here. I know that the height of the overall is 15. This is my slant height, I'm not going to use this. I'm going to use the one that meets at a 90-degree angle. So this height overall is 15. We have 1/3 pi times 12 squared times 15. So this whole thing gets typed in there. You can type it in all at once or you can type it in separately. Does not matter. So we get our volume is about 2,261.94, round on that one, 7. And this is millimeters cubed. Okay, anything that goes to a point, we're going to put a 1/3 in front of it. Last problem I'm going to go over with you. It says the Louvre Pyramid has a metal and glass structure that serves as the main entrance to the Louvre Museum in Paris, France. The pyramid has a volume of 8,820 cubic meters. The base of the square with sides that are 35 meters long. So we're going to start off with my basic formula for anything that comes to a point. 1/3 big B times H. I'm going to substitute in my area formula for a square base. So that is going to be length times width, or base times height, however you want to say it. And then the height of the overall, how tall that pyramid is. So base, height of the base, and then height of the overall pyramid. So now let's plug in. We know that we have 1/3. We know that the sides are 35 by 35. And the question actually says find the height. So I don't know the height, but I know that the volume is 8,820. It says volume and it also says cubic meters. So both of those are giveaways. So I'm going to go ahead and solve for this right here. So we get 8,820 equals 408.3 repeating times H. And then we want to do inverse operation. So I'm going to divide by 408 on both sides. So we get the height. Let's see. So I'm going to do, it's going to be 21.6, and this is meters. Okay, I'm going to leave the last one for you to go ahead and do on your own. Okay, for this last one, it says that we have an ice cube tray that makes spheres, so we needed to find the volume formula for a sphere, 4/3 pi r cubed. And then I know that the radius is 2.2, so I have 4/3 times pi times 2.2 cubed. That gives me 44.602 centimeters cubed for one of the spheres. But it says that there are 6 of them, so I took my one answer and multiplied it by 6. So the entire volume for all 6 cubes would be 267.613 centimeters cubed.